So this lesson will be on percents, and this comes out of your book, section 3.1, 3.2, 3.3. When it comes to percents, it's a unique way of trying to express the meaning of something. Some things that, sports has a lot of data in it, and percents are expressed in a lot of data. Um, One of my favorite football players is Brett Favre, and, his first career start, he completed 21 of 39 passes. He made 3 TDs and 2 interceptions. But something that they track is like passing percentage. So passing percentage would be like this 21 out of 39. He completed 21 out of 39. I could change that to a decimal, 0.54, by changing that to decimal. We can also use a calculator on that. And then we can also change that into a percent. It'll be 54%. So he completed 54% of his passes. So from that perspective, he had a fairly decent day, but, even though he won, some other stuff they look at is those 2 interceptions would be kind of another mark that offsets some of his stuff here. So a lot of times in football, you see more of a fractional concept, 21 of 39 passes. In baseball, Pete Rose is one of the all-time best players. Well, that's all about opinion, I guess, but when I grew up, he's somebody I thought as a player, but as he got older, he did get into some trouble. But anyway, Pete Rose for his entire career though had a batting average of 0.303. Okay, 0.303. Well, if I move the decimal 2 places to the right, that would be like 30.3%. Or if I change it to a fraction, it'd be 303 out of 1,000. So in other words, every 1,000 at bats, he would have 303 hits. So something to that effect. Or if I look at it from another perspective of a fraction, it's about 3 out of 10. So every time he gets to bat, every 10 bats, he would have 3 hits. So, that doesn't sound all that great, but in baseball, that's actually very, very good, especially for a career. Another thing is, so like I said, in baseball, a lot of times you'll see batting averages. If you ever watch it, it's all in a decimal form. Pete Rose bat 303 for this career. Okay. So try to bring that to life. Sometimes we can express it either as a percent or even as a fraction to give it some more meaning. Another thing you may see is, like 91.55% of Americans have access to at least one vehicle. So this is a study. I can't remember what year this is done in. This is one of my favorite cars. It's a Mustang. 91.55%, that to me is a very high number, especially if we talk about all Americans in our country. Now, if I change it to a decimal, that would be 0.9155, but that doesn't have much meaning. Or if I change it to a fraction, remember, this is the tenths, hundredths, thousands, 10,000ths place, so that would be 9,155 over 10,000. So what I could do here is, out of 10,000 people surveyed, 9,155 people had access. So that looks pretty like, wow, everybody has access to a vehicle. So what we pick up on is percent is a cool way to represent a decimal or a fraction. Sometimes percentages paint a better picture than a fraction or a decimal would. So we kind of start trying to express, especially when it comes to some of the applications, express things as a percent because we have a better understanding of the situation. Either we're at risk or we're doing great or whatever it is that we're studying. So the catch though is the percent symbol is not on a TI-94 calculator. But the good news is percent means per 100, or in other words, divide by 100, basically is all it really means. So if I gave you 100%, we know that 100% means all. So if I express this as a fraction, it would be 100 out of 100, which would equal then 1 whole. Because remember, if the numerator and denominator are the same, that creates the fraction of 1, or the whole number 1. So 1 whole means all of it in this situation. If I divide by 100, remember the decimal is at the very end, and if I move it 2 places to the left, that would give me like 1.00. And remember, those trailing zeros there are unnecessary. And we can just write that as 1, just like your calculator would. So 75% means 75 out of 100, which also we could write this as 3/4 if we reduce that. That also could be like if I divide by 100, I can move the decimal 2 places to the left, and that would be 0.75. So 50%, by definition, if I write that as a fraction, that would be 50 out of 100, because percent means per 100. So I could put the 50 over 100. And if I reduce that fraction, 50 out of 100, we can kind of see these trailing zeros could divide out because A represents tens. I'd have this 5/10, and the numerator and denominator both can be divided by 5, and 5 goes to 5 one time, and 5 goes in 10 twice. Or you may just remember that 50% means a half. So you may have that math fact memorized. Also, we know that, 50% means 50 divided by 100. So if I move the decimal 2 places to the left, I would end up with this 0.5 or 0.5. A lot of times they like to have that 0 in front there on the calculator. Again, it's optional when you input it though. So 25%, notice that means 25 out of 100. And we know that 25%, I can divide the top and bottom by 25, and that will give me the fraction of 1/4. We also can do 25 divided by 100, move the decimal 2 places to the left, and that would give us then our 0.25. 10% means 10 out of 100. 10 out of 100 means the same thing as 1/10, or divide by 10. So if I do 10% divided by 100, if I move my decimal 2 places to the left, I end up with this 0.10 or 0.1, which we would say is 1/10. So notice that percents can be changed into a fractional form and a decimal form. So percent, decimals, and fractions are interchangeable, as we said. One thing we can do is if I give you a fraction 2/5, if I can make the denominator 100, I can change this easily into a percent. And I do know that if I multiply 5 by 20, I know 5 times 20 is 100, because I know that 5 nickels is $1. So that's my nickel math. So back in the day when I actually worked with coins. So if I multiply the numerator by 20, I would get then this as 40 out of 100. And since the denominator is 100, I can replace that then with 40%, because per 100 is the same thing as the percent symbol. So if the denominator is 100, I can always go straight into a percent notation. So if I have 7 out of 25, notice that if I can make the denominator 100, then I can change this easily into a percent. And I can by multiplying the denominator by 4 and multiplying the numerator by 4. And this will give me 28 out of 100. And this will give me then, of course, 28%. So some fractions can be easily changed into a percent. So we have 35 out of 50. So again, if I can make that denominator 100, all I got to do is multiply this by 2, multiply this by 2. That would give me 70 out of 100. And that would be, of course, 70%. So again, some fractions can be easily converted into a percent. So a lot of times when I make up tests, that's why I like to ask like 20 questions or 25 questions or 50 questions, because those are easily determined as percents. And that's how our grades are figured out in this class, is by percentages. So changing a percent to a decimal to a percent is probably one of the easiest things to do. And remember, decimals can be changed to fractions using a TI-84. So let's change the following to decimals. To do that, what we do is we drop the percent symbol and move the decimal 2 places to the left. In other words, divide by 100. To change decimals to a percent, we're going to move the decimals 2 places to the right and reattach the percent symbol. So if I want to change this fraction to a decimal, because notice that I can't really multiply 8 by a number to make 100. So what I can do is pick up my calculator and put this 5/8 into the calculator. Let me get this slid over here. Let's see if I can get that to work. Try that again. Okay. So remember, the fraction button is in this F1 key up here. So to get to that F1, I have to hit the alpha key, hit F1, and then I got this format N over D. So if I choose number 1 there, I can now put 5 on the top, use my directional arrow, and I can put an 8 on the bottom, hit enter, and I get this 5/8. Also, under the math button, I can just change that to a decimal by using number 2, hit enter. That gives me 0.625. Now, another way to do it is, 5/8 is simply a division problem. So you could just simply type 5 divided by 8 into the calculator, and that gives you 0.25, 0.625. So I can easily change a fraction, let's see if I can get that, a fraction to a decimal. And then I can move the decimal 2 places to the right, and that can become 62.5, and just stick back the percent symbol, and that gets me back to a percent of 62.5%. So 5/8 is a little bit over 50%. Notice that 2/10 is already a decimal. So all I got to do is move the decimal 2 places to the right. So if I do that, so I got my decimal here, and I got to move 1, 2. So remember, I got to use 0 as a placeholder there. So that becomes 2, 0, stick on the percent symbol, and that becomes 20%. On a calculator, you could also just go 0.2 times 100, hit enter. That gives you 20, but you got to remember to stick back the percent symbol because the calculator does not have that on there. So if I have 0.1258, again, I can make that become a percent by moving the decimal 2 places to the right. So it goes between the 2 and the 5. So it becomes then 12.58%. Or again, using your calculator, you could go 0.1258 times 100, and that would give you 12.58. But remember, we're trying to change it to a percent, so we got to stick the percent symbol back on it because percent still means per 100. So we can't just write 12.58 because then they wouldn't be equivalent. Percent means per 100, so keep that in mind. So if I want to change 4 3/10 into a decimal, you can just use the calculator if you want to. You hit the alpha button, hit the F1 key. Notice that number 2 has that mixed number format. So I have 4 3/10. So I hit the 4, arrow over 3, come down, put the 10 in, hit enter. Notice that gives me this fraction. I can use the math button and change it to a decimal, and that gives me 4.3. Or if we just, excuse me, where do we go here? Okay. So that would be 4 3/10 or 4.3. But remember, 4 3/10 does mean 4.3. So we may not need a calculator if we recognize that 3/10 just means 0.3. Okay. So if I have 36.2, if I want to change this to a percent, I got to move the decimal 2 places to the right. So if I move the decimal 2 places to the right, that becomes then 3620. And then remember, I got to stick on a percent symbol. That becomes 3,620%. So some percents are very strange to us. But if you play the stock market, people do not want percents that are under 100%. They want percents that are over 100%. That's high risk maneuvers. Most of us want small gains, so we're happy with a 12% gain or 16% gain or 20% gains. But the stock market these days is very aggressive. People are looking for extreme growths, and that's what makes the stock market so volatile. So if I want to change this percent to an equivalent fraction decimal, and we could round necessary to the thousandths place, which in other words is 3 places past the decimal. Let's see what we can do with these problems. So 36%, remember, 36% means 36 out of 100. Remember, I can move the decimal 2 places to the left and make that a decimal, 0.36. So that'd be the decimal form. Now, you also can type in 36 out of 100 to make it a fraction. And again, you can use the alpha F1 button. You can use the N over D format, and you can put the 36 over 100 into this calculator, and it'll give you this 9/25ths. So 0.36 or 9/25ths would be the fraction form. So you don't have to reduce fractions by hand. You can also let the calculator do it. So 63 and 2/3%. Notice that this is going to be the same thing as 66 and 2/3 over 100. So if I want to make this a problem in the calculator, so we can do it this way. We can type in the 66 and 2/3 to start with by using the alpha F1 button. And that's the mixed number format, number 2. So I have this 66 come over, 2 come down, 3 come out. Now, if I want to divide that by 100, I can just hit the divide by 100 like that. That gives me 2/3. So if I want to change that to a decimal, I can hit the math button and number 2, and that'll change it to a decimal for me of 0.666666667. And notice how on decimals it said round to the nearest thousands. So to round 3 decimal places, I actually have to go out 4 decimal places. So that would be like so as a decimal, it'd be like 0.6666. But if I want to round to the thousands place, I underline that 6, but the 6 after it tells me to round up. So that's going to be about 0.667 or 2/3 as a fraction. So if you want to note a little memorization tool, 66 and 2/3%, notice that 2/3 is setting right there on the end. And that's the way some of us remember it is we just kind of memorize that 66 and 2/3 is percent is the same thing as 2/3 because that 2/3 is just looking at us. So if I want to do 1/5 percent, that would be like 1/5 again divided by 100 because it's per 100. So if I want to do that one using a calculator, I can type in that 1/5. So I hit it to alpha F1 N over D, and I can go 1 down arrow 5, come out, divide that by 100, hit enter, and that gives me 1/500. And then if I want to change that to a decimal, I can also divide that by, or I can use the math button as well and just say, hey, change it to a decimal for me. So I end up with this 0.02 and this 1 over 500. So 0.002. And also I don't have to round that one because that just goes out to the thousands place. And also as a fraction, it would be 1 over 500. So I can change those into those notations. So 1/5 percent is not a whole lot. It's like for every 500, you get 1. So it's not very much because I kind of look at it probably. Sometimes it's easier. Sometimes look at things as fractions as well, depending on the situation. So if I want to change this decimal, or I'm sorry, this percent into a fraction and a decimal, I can just type the 18.75 over 100 into the calculator because again, percent means per 100. So if I type in 18.75, I divide that by 100, hit enter, it's going to give me this 0.1875. And remember, dividing by 100 just means to move the decimal 2 places to the left. So that would just give me 0.1875. So you can bypass the division of the 100 on the calculator because all you really got to do since you're dividing by 100 is move the decimal 2 places to the left. We'll try again, 0.1875. Now notice this one's actually got to be rounded to the thousandths place. So that would be actually 0.18. And that 7 is what we got to round. And this 5 would tell me to round it up to the next place. So that 7 actually rounds to an 8. So that would actually be 0.188. Now, if I want to make this a fraction, all I got to do is hit the math button, use number 1 to turn it back into a fraction. That gives me 3/16. So 0.118 would be the decimal notation, or 3/16 would be the fractional notation. So for every 16, like we're talking about Pete Rose, for every 16 at bats, he would get 3. So that would be like a batting average of 188, which is not so good. Okay. So let's see what else we got here. Solving percent problems using the formula. So percent is a very common in problems and that we may come across. So they're all over the place. So when it comes to applications, percents is kind of the gateway to starting application, working with applications, word problems. So where we sometimes come across percent problems is, a lot of times, in our work, we got a 7% raise. Well, what does that mean? Do I want to trust them to do it correctly, or do I want to verify my math to see if that's right? So just keep that in mind. If your raises are actually based on percentages, then you may want to double check some of that math, because that's not as concrete as all that. So they can disguise the math. So that's what's tricky a lot of times with percentages. It's not clear of who's getting what in that sense. So raises are a lot of times expressed as percents. Taxes, like sales tax, or for us, I got a paycheck and I've got state taxes and got FICA is taken out of my check, which is also a percentage. So it's like Social Security. So a lot of taxes are taken out of your paychecks, but they're all created as a percent. I think Kentucky sales tax is like 6%. So we got that going on for us. Other things, like markups and discounts. So a lot of times if you're at a store, a discount will be expressed as a percent, or the markup will be some type of percent. Especially if you're trying to make a profit, if you're actually the person who's doing the work and doing all the investing, you may want to mark stuff up to make a profit. A lot of times that's like if you have somebody in construction, things like that. You're buying all the materials, you're supplying all the work, but you also want to take home some money. So doing some of your own math, you can try to figure out what kind of percent markup you need to make to take home a fair amount of money for your day's work. So a lot of times, like I said, all kinds of statistical data is often described as a percentage. Especially in sports, you'll see percentages in sports all the time. But other things that there's always people surveying you. Especially if you're out there in social media, they're collecting statistics and they're trying to find out percentage wise what are the best ways to serve those who use social media. So there's always this collecting of data, and a lot of that stuff is expressed as percentage math. So when it comes to actual solving word problems, they typically involve three things. They have this word, part, whole, and percent. So the part a lot of times is denoted as the capital P. The whole, a lot of times they'll use the word base as the whole. The base or the whole is also considered like the original amount, initial amount. Sometimes, those are also what we call the starting amounts. What's happening at the beginning, starting amount or beginning amount. So that's what the base is. Where are we at the very beginning? And that's what initial kind of means. The last thing we have is what's called the percent. So percent is this, but a lot of times in our books, they'll use R for percent. That's the rate of percent. So an interest rate is a lot of times expressed as a percentage. So sales tax is actually a sales tax rate of 6%. So R, a lot of times denote percent or rate. A percent or rate is describing the part that is taken or added to the initial or base amount. So a percentage is used to just discover how much of the base that we actually get or have to take away. So that's where that percent comes in, but it's based on the initial amount. So if I wanted to determine the sales tax on a jacket, sales tax rate in Kentucky is 6%. You'll need to set it up using this format: base, part, and rate. Now keep in mind, for us, 6% means 6 over 100, which is going to be, so for every $100 spent, we pay $6 in taxes. That would be the sales tax. So that's what 6% means, is for every $100 you spend, you have to pay an additional $6. So if you buy something for $100, it's going to cost you $100 and $106. Now, I can also change this to a decimal notation. That could be 0.06 over 1. So what that means is for every dollar spent, they're going to charge you 6%. So if I buy something for $5, I got to pay that 6% 5 times. So 5 times 6%, 5 times that 6% would actually be like 5 times 6 cents. And 5 times 6 cents would actually be 30 cents. So it'd be like $5.30 in the end. So if you buy something here in Kentucky for $5, you have to end up paying an additional 30 cents before you walk out the door because there's a sales tax. So what we come up with is, if you can identify the base, the part, and the rate, we have a strategy to solve these problems. So again, the base in our problem is the initial amount. That's the jacket. That'd be the $25 or just 25. The part in this problem is we're trying to determine the sales tax. We don't know that. The sales tax is unknown to us. That's the part that's going to be added, or in this case, added to our $25. The rate or the percent is given to us. That's the 6%. Now, since we don't have a percent symbol on our calculator, we typically just change it to a decimal by moving the decimal 2 places to the left to make that 0.06. So when it comes to solving percent problems, we have this: the percent times the base is going to equal the portion. Or a lot of times they'll just use RB equals P instead of that. So in our problem, the rate was 0.06. The base amount was 25. And we do not know what the part was, so that would just stay as P. So if I multiply 0.06 times 25, that would tell us our sales tax. So let's see if we can kind of put this together. So let me just clear this all out and make a fresh one. So if I have 0.06 times 25, that'll give us 1.5. But since we're talking money, we probably want to say $1.50 would be equal to P. That would be our sales tax. So our sales tax would be $1.50. Now, if I want to find the final amount, I would have to add the $1.50 to the 25, and that would be our final amount. That would be like, what, $26.50. Formulas a lot of times are organized using little boxes and stuff. So if I draw a box, let me bring this back over. So if I draw this rectangular box, we divide the box into 3 pieces. So I draw a line across the middle to start with. Then we bring another line here, and notice how we have the part is here, the rate or the percent is here, and the base or initial amount is over here. So the way this works is, if I was going to solve this problem, I would draw my box, and it doesn't have to be perfect, just big enough to stick stuff in it. The part we don't know, that would stay blank, but the percent was 6%, or we have to change it to a decimal of 0.06, since our calculator does not have a percent symbol on it. And our base amount was 25. What this kind of says is, if things are side by side, this tells me to multiply. Now, if it was top to bottom, like if we were looking for the initial amount, the part and the rate would have to be divided. Or if I was looking for the rate, the part and the base would have to be divided. But this tells me that we just got to multiply 0.06 times 25, and that would have gave us then this 1.50. That would have been our portion, that we would have to pay in taxes. So let's look at another example. A mail order pharmacy offers Allegra at 66% of the retail price of $35.99 for a month's supply. What is the mail order price? So our mail order price is going to be 66% of this. And again, the retail price is like the original price, $35.99. So our mail order price is only going to be a portion of the original amount. So we're looking for the part. So in this problem, we have to identify the base, we have to identify the rate, and we have to identify the part. So the $35.99 seems like that's the initial amount to begin with. The rate is 66%, which we're going to change to decimal of 0.66. And the mail order price is what we don't have. So again, when it comes to formulas, I like to use the box method. So the rate would go here, 0.66, and the base goes here, $35.99. And again, we don't know the portion. But since these are side by side, this tells me that I can multiply those together to come up with our answer. So if I use on the calculator 0.66 times 35.99, that gives me then 23.7534. Since we're talking money, though, we have to round to the hundredths place. So this 3 would tell me to keep it at $23.75. So we do the $23.75. So our mail order price would be then let's say $23.75. I'm probably about to go back and look at that. That's how good my memory is. So what is that? $23.75. Yeah, it was. Okay. So using the percent formula, R times P equals P, let's figure out what 30% of 18 is of what number. So for me, the formula, what I'm going to do is just use the box. So I have, P's up here, R's here, and B's here. So remember, the rate is the 30%. So that's going to be going here, but I have to make it a decimal. So it's going to be 0.30. Again, I could divide by 100 on a calculator, just move the decimal 2 places to the left. 30% of what? Of 18 is what number? So the thing to pick up on in this also is we always take a percent of the whole or base. So whatever follows the of is always going to be the base. Whatever follows the is always going to be the portion that we get. So we always take a percent of the whole. So that of is going to be a clue that's going to be our initial amount. And then we're actually looking for the part. So again, that 18 is going to go in this spot here. So we're going to just multiply, 30% times 18. Well, really, that's just 18 times 0.3. So 3 times 8 is 24, carry my 2. 3 times 1 is 1, plus 2 is 5. And I got to move the decimal over 1 place to the left, 5.4. So 30% of 18 would be like 5.4. So that would be our answer. So 5.4. So what percent of 88 is 77? So if I look at this problem using this formula, but again, I'm going to use the box method. Again, you may want to make the box big enough that you can put stuff in it. So I'll kind of cut it in half, and then, so the part is up here, the rate is over here, and the base is over here. So what percent of 88 is 77? So we don't actually know what the rate is. Notice that we always take percent of the whole or the base. There's that of again. That of kind of tells me that 88's got to go here. And then the 77 would have to go on the top. Now, since we have a top and the bottom, this tells me that we have to be dividing. So 77 divided by 88. So let's go ahead and do that. So I'll clear this all off again. So 77 divided by 88, and that's going to give me 0.875. So if we come back over, I get this 0.875 would be here as our answer. But remember, we're looking for the percent. So we still got to move the decimal 2 places back to the right. And that becomes then 87.5%. So when you move the decimal 2 places back to the right, remember you got to stick on the percent symbol. And those are equivalent. So just keep that in mind. So another application here is we have Nancy Botano expects to receive $18,000 in bonuses for managing the media center at the Olympic Games. If the bonus is 24% of her salary, what is her annual salary? So again, they're asking us to use this box method. So let's see if we can kind of figure this all out using the formula. So the part would be up here, the base would be over here. I'm sorry, the rate would be over here, and the base would be over here. Base would be over there. So Nancy Botano expects to receive $18,000 in the bonuses. Notice that a bonus is actually just a part of her salary here. If the bonus is 24% of her annual salary, what is her annual salary? So notice that her annual salary is actually her whole amount or initial amount. So the annual salary is what we don't know. The 18,000 is actually the portion of her salary. It's called a bonus, and the percent is also a bonus, and that's kind of a clue. If the numbers are talking about the same things, they're related, and that's the key. The percent and the part will always be related to each other because the percent is describing the part. So that means we have to have a 24% here, but have to use a decimal of 0.24. So this just has top and bottom. We have to use division to solve this problem. So if I use my calculator, I have 18,000. If I actually divide that by the 0.24, this will give us her actual annual salary, which was actually 75,000. So that makes better sense there. So 75,000 would be her actual annual salary. Now, some percents can be solved mentally using either 10% or 1%. 10% can mean 1/10. And remember, 1/10 can mean divide by 10. And remember, dividing by 10 just means to move the decimal one place to the left. 1% can mean 1 out of 100. 1 out of 100 can mean divide by 100. And remember, dividing by 100 means to move the decimal 2 places left. So 10% essentially means to divide by 10 or moving the decimal 1 place to the left. 1% essentially means to divide by 100 or move the decimal 2 places left. So if I want to mentally find 10% of 28,000, all I got to do is move the decimal 1 place to the left. In other words, just drop a 0. So that'd be like 280. I'm sorry, let's see here. Let's try that again. I'm just dropping 1 0, so I should still have 2 zeros. So I should have a 2, 8, and 2 zeros. And so therefore, the comma would go there. So 10% of 28,000 would be 2,800. So if you're trying to buy a house, a lot of times they're asking you to put 10% on something. To put 10% on something just means to drop one place value over what's left. Basically, is your estimation of what you're going to have to pay. Another strategy we have in percent problems is what's called the proportion. So if I have the part over the base, that's going to be equal to the percent. But remember, percent is going to be the rate per 100 because we're going to change that percent back. So in our formula up there, notice how we had, R times B is equal to P. In algebra, we can actually divide both sides by the B, and we would have then R equals P over B because these B's are going to divide out. And percent is actually something over 100. So we have this formula, P over B equals R over 100. So notice how we have 3 spots open in percent math. So instead of the box method, sometimes we can use what's called the percent method. So 20% of 375 is going to be what number? So again, using this P over B equals R over 100. One of the things we pick up on is the of is indicating the whole amount. So we know that the 375 would go here. So really we have these 2 dashes equals and another dash there. So dash equals dash. So those are fraction bars. We already know 100 is locked in over here. So the question is do we know the part or do we know the base? I'm sorry, do we know the part or do we know the rate? The 20% is given to us. The way this works is the 20% is actually written as 20 over 100. This time we don't actually change it to a decimal. We change the 20% to a fraction, 20 out of 100. So that creates what we call a proportion, a ratio equal to a ratio or a fraction equal to a fraction. So the thing we don't know is this guy right here. A lot of times, instead of using a question mark, we start to use algebra principles, which is actually an X. So one of the things we learned is if you cross multiply, those fractions have to to equal each other. Those cross products have to equal each other. So we learned that 100 times x must equal 20 times 375. So if I have 375 times 20, I can ignore the 0, bring it down. 2 times 5 is 10. 2 times 7 is 14, 15. 2 times 3 is 6, plus 1 is 7. So it's going to be 7,500. So we learned in math, though, is if 100 times x equals 7,500, you can go backwards and divide. So x is going to equal 7,500 divided by 100. Notice that dividing by 100 means you just lose 2 decimal places. I would just end up with being 75. So 20% of 375 should be 75. So 20% of 375 would just be 75. So that's how we can use a proportion, is we kind of cross multiply and divide. That's our pattern. So if I want to do 3/4% of 90 is what number using a proportion? So what we have here is our little fraction bars, our equal sign, our fraction bar. 100 goes here. Notice how, again, this is very similar. The percent of the whole is going to equal the part. So this is the rate. This is the base amount. What we don't know is the part. So the 90 would have to go here. We don't know the part that is going to be x. And then the percent is 3/4%. So what we do is we put the 3/4 over here and we just put it over 100. And the percent just becomes per 100. So that's how we do it as a proportion. So what we can do now to solve this, though, is we cross multiply to start with. We go 90 times 3/4. And then the remaining number is the 100 we divide by the 100. So let me see if I can put this together. So 90 times 3/4. So 90 times then, and to get the 3/4, I can hit alpha F1 and do N over D. So 3, oops, that don't look right. So I'm try to get 75, I'm sorry, 90. 90 times alpha F1. Oops, I didn't get my multiplication symbol there. 90 times alpha F1, number 1, and do 3/4. And then come out, hit equals or enter, and then just divide that by 100. Hit enter. That gives me 47/40. So the answer is 47/40. Oops. Or if we needed, I'm sorry, 27/40. So if we want that to be a decimal, we get the math button and tell it to turn it into a decimal. Hit enter. That's going to be 0.675. So you can use either one of those answers to solve that. Okay, so if I want to do 12.5% of what number is 43. So again, notice how this is going to be our rate. This is our base amount, and this is our part. So using our proportion, we don't know the base, that's going to be here. The part we do know is the 43, it goes there. The percent is 12.5%. So what we do is we put the 12.5 on the top. And remember, percent means per 100, so we put that over 100. This becomes a proportion. So again, we multiply the diagonal numbers first in this method, and then we're going to be dividing by the remaining number, which is that 12.5. So let's see if we can do that. So 43 times 100, well, that's just really 4, 3, and 2 zeros. So I'm going to just do that mentally. And if I want to divide by 12.5, remember, half is just the same thing as 0.5, so it's probably easier to just type in 12.5 instead of trying to type in the 12.5 in there, but you can. And that would give us 344 as our answer. So 344 would be here. Okay. So 72%, or 72 is what percent of 216? So notice that there's this percent again of, so we know this becomes the base because it's always associated with the percent of something is the original amount. So that means this over here is the part because it's associated with the is, and we don't know what the rate is. We don't know what R is. So in doing this problem, we have the part would be 72. The 216 goes here. We do not know what R is, but we put that over 100 in our problem. So what we got to do is figure out what X is here, which is our rate. So again, we can use the calculator a little bit here. So 72 times 100, well, that would just be 7,200. That'll look right. So 7,200. And then I'm going to divide that by the remaining number, which is the 216. And so this gives me this 33.33333. So this one looks like we could probably round it to 33.33. This is also 33 1/3%. So keep that in mind if they want this in another form. So what this becomes then is 33.33 per 100, which we then express as 33.33%, because you remember the 100 just turns into a percent symbol. So really, once you get what X is, all you got to remember is to stick a percent symbol on it, and that is going to be your answer. And this is also commonly known as 33 1/3%. If it's not rounded, this would actually be the exact answer. So in working with percent problems, these are some of the things that you may be looking for, as far as some vocabulary. So if you want to pause the video and just look at those a little bit, you can. So solving some more applications, and this time you can use any method. I'm going to just go ahead and I like the box method most often, so I'll probably see if I can make the box method work for us. So a cast iron contains 4.25% carbon. How much carbon is contained in a 25-pound bar of cast iron? So to me, reading this is my rate because it's a percent. How much carbon is contained? Carbon is only a part of cast iron. So this carbon is something that we're looking for. So that's going to be our P. The 25-pound bar of cast iron represents the whole amount that we have present. That's going to be our initial amount or our base. So using my box method, we know the rate would go, the part would go here, the rate goes here, and the base goes here. So remember, the rate though has got to be in a decimal. So if I move it 2 places to the left, that's going to be 0.0425. Again, you can type 4.25 divided by 100 to the calculator to get the same answer. And then you have this 25-pound bar. And we don't know what the part is. But notice that since this is side by side, this is a clue that these are, the relationship is multiplication. So if I have 0.0425 times 25, that gives us then 1.0625. So what we end up with then is 1.0625 pounds of carbon. That's how much carbon is in a 25-pound bar of cast iron. So it's important to pay attention to labels. I think these labels are probably already there in my lab. All you got to do is typically just write the number in. So if I have 3,645 rolls of landscape fabric, if they're manufactured during one day, after being inspected, 121 of these rolls are rejected as imperfect. What percent of the roll is rejected? Round to the nearest whole percent. So they give you some instructions here. So again, I'm going to use the box method as my choice since they're not telling me what to do. If they tell you what to do, then it's basically either the formula or the proportion model. So the 3,645 rows are manufactured during one day. That seems like the whole amount. So that's the base amount, the initial amount. After being inspected, 121 is another number. This seems to be the part that was rejected. So it seems like that's the portion. What percent of the rows are being rejected? That seems like that's the R. That's the part that's being rejected as a percent. So again, we have the part, the rate, and the base. In this problem right here, we know the 121 is here. We know the 3,645 is here. What we don't know is the rate. But in this relationship, we know this, since this is top to bottom, it makes a fraction bar or a division symbol. So using my calculator, I'm going to put in 121, and I'm going to divide that by 3,645. That's going to give me this 0.0333, all that stuff. So remember, though, I got to move the decimal 2 places to the right. That's going to be like 3.3. And 3.3 to the nearest percent would be just 3%. So keep that in mind. We have this 0.0031. 0.0031. Is that what we had there? I think I looked at that wrong. I think it was 0.0331. 0.0331. Yeah. Yeah, my memory just doesn't quite go full tilt there. So 0.0331. That's your rate as a decimal. But remember, they wanted us a percent. So with the decimal 2 places right, that gives me like 3.3%. But they say round to their whole percent. That means round to the ones place. So this 3 would say keep the 3 the same, and this would turn into then 3%. So 3% were rejected that day. That's what you want, a low number there. If you're not getting a low number, then something is not right. Something's got to get fixed. So let's look at another application. 385 defective alcohol swabs were produced during a day. If 4% of the alcohol swabs produced were defective, how many alcohol swabs were produced in all? So notice that we're looking for in all. That seems like we're looking for the base. The 385, notice that was just the part that were defective. That's the P. The 4%, that's going to be the rate that were defective. So again, I'm kind of picking up the pieces to this problem. So again, I'm going to use the box method as my strategy. It's just a better organizer and quicker. So again, I have the portion, the rate, and the base. And the portion was 385. The rate was 4%. But remember, we have to use the decimal form of that. That's going to be 4 over 100, or 0.04. So again, notice how we have a fraction bar here. That means we're going to be dividing those two values. So if I do 385 divided by 0.04, hit enter, that's going to give me 9,625. So 9,625 alcohol swabs were produced. And only 385 were defective, 4%. So that's not bad, I guess. 4% is still a nice little number. So let's look at, looks like we just have one more maybe. Yeah, looks like one more. Excuse me. An employee has a net salary of $576.89 and a gross salary of $745.60. What percent of the gross salary is the total of the deductions? Round to the nearest whole percent. What percent of the gross salary is the total of the deductions? Let's see here. So what we got going on here, the gross salary is the amount before deductions. The net salary is the amount after deductions. What we were talking about is total deductions. So the total deductions would have to be the difference between these two values. So one of the first moves is we have to go 745.60, and we have to take 576.89. We have to subtract those to get the deductions. I'll kind of abbreviate deductions there. So let's slide that over. So 745.60, that's the money I had to begin with. If I subtract my take-home pay, the 576.89, that tells me how much they actually took out of my check. 168.71. So 168.71. So it looks like they gave us a little curve here on this one. They didn't tell us the deductions, but they gave us information to find the deductions. So if I look at this problem now, use my box method, we're looking for the rate. So we have to know the part and the base. Well, the part is about the deductions. So that's where that 168.71 is going to go in. That's the deductions. That's the part that took off. And my gross salary would be my original amount or whole amount. So the 745.60 would be my base. So again, I have that fraction bar there. That would be telling me to do some division on that. So I have 168.71. I'm going to divide that by 745.60. And that's going to give me then 0.2262. So 0.2262. So I have this 0.2262. And remember, we're talking about the rate. So again, right now the rate's in a decimal form. We got to move 2 places to the right. So that's going to be 22.62%. But they want to round to the nearest whole percent. So that whole number is this 2 here. And that 6 is what I need to use to round it. And since that 6 is up, that means we move the 2 to a 3. So this is around 23%. So that's pretty darn good. That's a good application because that's about how much taxes are taken out of my check. It's about 23%. So that's a good example, actually. So 23% would be the percent of deductions. Okay. So if you ever want to try to figure out your percents on your check, this is the kind of stuff you would be doing to determine percentages. So because they always talk about that in the news and stuff about taxes and percentages and stuff. Well, this is how you get a real accurate account for yourself of what's going on. Well, y'all have a good day, and hopefully you found this video helpful.